Hello and welcome to another section in further mathematics. Today we'll be talking about we'll be looking into the topic the chain rule. Now when we talk about the word chain, I don't think it's anything different from what we used to knowing about the chain in real life. Chains means putting points together. Like we have points A, we have points B, and we have point C. Now, if you link A to B, link B to C, you connect A to C as well, then you formed a chain. Same thing is applicable here. Now, when you talk of chain in further maths, it simply implies if P and Q and R are three different sentences such that P implies Q. You know, I said something about implying. And Q implies R, then P also implies R. It's just like saying, let me use one example here. If I say, okay, men are rich. John is a man. So therefore, John is rich. Have you seen how I linked it? Now, the link between this and this is the word man and man. And now the link between this and this is John. But if you watch between the first and the last, there's a link. Rich and rich. So, if this is, let me say A, this is B, and this is C. Chain means getting the link. This is related to this. But you state how this is related to this that can also connect this. So, men are rich. John is a man. So, therefore, John is rich. So, this is chain. You're trying to, you know, originally, men are rich. John is a man. There's a link between these two. Then, likewise, John is a man. John is rich. There's also a link between these two. Now, the link between this and this can also link this. So, that is what they call chain rule. Trying to create an indirect chain to three different or more sentences. You can even add another one. Men are rich. Banjul men are rich. John is a man. John is rich. Then John is a rich Banjul man. You see how you connected everything together. You're trying to form a chain relating the first to the last and the second form a Q in reasoning. So, okay, if there are three set statements such that P implies Q and Q implies R, then P implies R. Now let's see the sentence we have here. This is called a chain rule and it may have several links. Several, just like what I stated when I was giving this example. It can even have 20 links. For example, consider the argument. If a student works very hard, he passes his examination. If a student passes his examination, he is awarded. If a student works very hard, he is awarded a certificate. Now look at this. Let P be the statement, a student works very hard. That's number one. Now, the second one is, a student passes his examination is another statement. Then a student is awarded a certificate. Now we have three different statements. Now I want us to link them together. You can say, if a student works very hard, a student passes his exam, then a student is awarded a certificate. If a student works hard, he or she will pass his examination, then the student will be awarded a certificate. Now remember, awarding a certificate has a link with passing of exam, while a student working very hard has a link with passing of examination. Now you can't say a student works very hard, a student is awarded a certificate without jump. If you decide to jump the second one, the sense in it will not be that good. A student works very hard, a student is awarded a certificate. It's not everybody that works hard that is being given a certificate. But this awarding a certificate can only make sense at the link to this first statement. If you use the statement, a student works very hard, you create a link between them. A student passes his exam. So if a student works hard, he passes his examination, then a certificate will be awarded to him. Now, men are rich, John is rich. There's no, if you watch it, men are, what if John is a woman? So you have to put a link, a statement in between them that will link the first and the last. Then it will not make it a chain. All the statement will not be related. Men are rich, John is a man, then John is rich. So this is called a chain rule, trying to connect. Sometimes you can even have 4 or 5 statements that you wish to connect as such. Now, there's a part I want us to talk about. It's called disjunction. Disjunction means, will I say, statement of fact. Statement of fact. So when you're talking about statement of fact, it means if you state any fact, even if you make 3 different sentences and one of the sentence happens to be true, if one out of the 3 happens to be true, then in disjunction, according to the law of disjunction, then the entire statement is true. For example, and we use the word or in linking it. If I say, for example, if I should say, it is either John is a woman or John is a man. You know, humans are not hermaphrodites. We can't have the attributes of a man and at the same time have everything that classify you as a woman, classify you as a man. So it is either you are a man or you are a woman. So in such setting, like for now, and we use the symbol a V facing up to represent or. We don't say P or V. We rather use the word P like this. P this, then the V comes here. Now let's use the example that we are seeing here to illustrate this very disjunction. Banjul is in Africa, or 8 is an even number, or is the sentence. That is to say, 1 is correct. The 2 might be correct, 1 might be correct, but the 2 can never be wrong. So Banjul is in Africa, which is correct. We have the word truth. 8 is an even number, which is also correct, true. So automatically we confirm this statement as being true. So P or Q, that is to say, they are both true. We are just interested. Remember, I said disjunction means statement of fact. One just needs to be correct for the statement to be correct. All must not be correct. So in this other one, we have Banjul is in Africa, which is true. So automatically, our last statement is supposed to be true. Then 8 is an odd number, which is false. So we now say Banjul is in Africa, or 8 is an odd number. Since one of the sentences is correct, because you use the word or means they existed on its own. So Banjul, the conclusion is correct. Remember, I told you that the first statement is usually called the antecedent, while this is called the consequence. So when you say Banjul is in Africa, or 8 is an odd number, it's correct. You can say the human coming is a man or a woman. You are very correct, because if that woman is not a man, it's a woman. So Banjul is in Africa, or 8 is even. In as much as there's one idea that is correct, then the truth table produces truth in the relationship. So Banjul is in Africa, or 8 is odd number, so it's true. Banjul is in Asia is already wrong, or 8 is an even number, so it's true. 8 is an even number, so making this the conclusion true. Banjul is in Asia is wrong. 8 is an odd number, or 8 is an odd number. They are both wrong, so the conclusion becomes off. That's false. So that is how to prepare the table of disjunction. Now, if we now get to conjunction in logic, conjunction means co-unite. That is to say, the 2 sentences must be correct before you use the word truth. And in conjunction, if they both need to be correct, so this we have the sign of implication, which is implies here. So if the both sentences, we use in conjunction, we use the word and, not or. Or is for what? Or is the previous this thing, which is disjunction. Now conjunction means they must co-unite. They must co-unite for it to be truth, for it to be correct. So when you have the word and you cannot say he is tall and short. It's wrong. So you can say he's tall and handsome. Correct. He's tall and chubby. Correct. You can say he is tall and rich. Correct. But you cannot say he is tall and short. So that's what conjunction is talking about. And remember, in disjunction we use the symbol V. In conjunction we use an inverted V, a V that is faced downwards. So with this, what I want us to do now is, let's use the word and. Banjul is in Africa. It's correct. And 8 is an even number, so they are both correct. According to conjunction, that is when your statement is correct, because the antecedent is correct, and the antecedent is correct, and what else is correct? The consequence is also correct. So automatically the premises, what happens to be, or the conclusion of a statement under conjunction should be true. Remember, I said and. Banjul is in Africa. It's very true. And 8 is odd. 8 is never odd. So you can't say, since one sentence has false, so the statement is false. F. So this is F. This is the only truth. This, like I told you in conjunction, they both need to be true for it to be true. Now this is Banjul is in Asia. It's a lie. And 8 is even. So automatically this conclusion should be off, because this is wrong and this is true. In conjunction, you need to have the both being truth before you have a true sentence. Now in this other part, Banjul is in Asia, it's already wrong. 8 is an odd number, which is wrong. So your conclusion should be that the sentence that was being made by this young man is wrong, because Banjul is in Gambia, not Asia, and 8 is an even number, not odd. So your conclusion should definitely be wrong as well. Now when you're talking about equivalent statements in logic, two compound statements are said to be equivalent. The word equivalent means equal. Equal statement. Now we have equivalent statements. So if they are not equal, then the law of equivalence is being underruled. So let's use our rule in texting the question we have on the board. Two compound statements are said to be logically equivalent if they have the same truth value. I told you before now that this is called the truth table. So you use the truth table to check if these things are equivalent. Now let's use our rule. This is the antecedent, and this happens to be our consequent. Remember, I said when we have or, so one just needs to be correct for it to be truth. So let's go. This is truth. So at least one is correct, is truth. This is truth and false. At least one is correct. This is truth. This is false and truth. At least one of them is correct. This is truth because it's an or statement. This or this. And this is false. This is false. They are both wrong. So this is F. It's not correct. Now remember, the negative sign of anything means the opposite. So if this is truth, P, if P, this is just like a union or an intersection. If this is P or Q, now the minus sign of this should be F. I told us the minus of truth is F. Now the minus of truth is also F, and the minus of F is truth. Now look at the statement. Let's check if this is equivalent to this. Now let's come to this other table and see if what we have here will be what we have at the final value. Now we've gotten the value of this. Now let's check for this. This is true. This is okay. Truth, false, false, truth. So the minus of truth here is false. The minus of truth here is false. The minus of false is truth, and the minus of false is truth. Now to Q and the minus, this is truth, so this becomes false. This is false. This becomes what? True. This is true, so this becomes false. This is false, so this becomes true. This becomes true. Now, the last part is we want to check if, let's add the last line, bring it down, bring it here, put it to this point. Let's just add the last part of it. Now let's try something. Now this part is what we want to check, which is we want to put minus P with this, and Q. That's and. So the only place we have truth is when you have truth in both directions. Remember the law of and. So this is conjunction. Let's start between these two. FF is F. F truth is still F because it's not truth. We only have truth in conjunction when we have truth. Truth F is F, and truth is truth. So this point is now FFF truth. That's false truth, and this is false truth. So these two signs are equivalent. Thank you for joining us in this section. To refresh your memory on what we just discussed, please take the test that will appear on your screen. Do well to use this lesson notes on the platform for better information on the topic we've discussed. Feel free to always drop a question on the comment section. We'll be looking forward to having you next time in our class. Thank you. See you next time.